Remote sensing of the effects of a Category 5 hurricane making landfall. The study area for this project is Mexico Beach, Florida. In 1946, a group of businessmen bought the land to begin development, and in 1967 the town was established. The town is located just south of the Tyndall Air Force Base. Mexico Beach has become known for sport fishing. The town established the Mexico Beach Artificial Reef Association that has created more than 1,000 patch reefs. The program has attracted countless species of fish and other sea life to Mexico Beach. This made the area a preferred destination for sport fishermen. Unlike other coastal cities along the Gulf, Mexico Beach maintained its small town appeal. The town has restrained commercial development in order to protect the small businesses. Before 2018, Mexico Beach had a population of around 1,000 people and provided a quaint vacation spot for generations. Hurricane Michael devastated the quiet town on October 10, 2018, with the highest sustained winds of 160 miles per hour. The hurricane caused over $25.1 billion in damages, and the majority of all the houses and businesses were destroyed. This was the first Category 5 hurricane to hit Florida in over 2 decades since Hurricane Andrew in 1992. Hurricane Michael is the fourth Category 5 hurricane to make landfall in the U.S. Not only was the community destroyed, but also the environment. The forests, beaches, sandbars, and canal were all damaged because of it. The purpose of this map is to quantify the amount of change before and after the hurricane. The before image was collected on July 20th, 2018, 3 months before the event. The after image was collected on October 13th, 2018, 3 days after the event. The image was captured by digital globe, which has a high spatial resolution. Here are the raw satellite images of before and after the hurricane. Each image is notable from one another. This image shows image differencing between the before and after satellite images. The red color is for what has been changed from the before, the yellow is for what is the same, and the blue is for what is new from the after image. The image allows me to notice which areas has been changed. The purpose of this map is to see what type of classes will be classified before and after the hurricane. I ran the IsoCluster tool to find 5 classes. From the 5 classes, I was able to identify water, vegetation, grass, urban, and roads. The water, vegetation, and grass classes were close to accurate. The urban and roads classes were similar to each other, and the tool may have classed roads as urban and vice versa. The biggest problem was that sand was classified as urban. Other problems were that in the before image, the sandbar was classified as vegetation, while in the after image, the sun glint was classified as a mix of vegetation, grass, and roads. Overall, the unsupervised classification provided a useful representation of the changes caused by the hurricane. The purpose of this map is to see what types of classes will be classified before and after the hurricane in more detail by providing training samples. In the before image, I classified water, buildings, roads, green vegetation, brown vegetation, sand, and sandbar, while in the after image, I had the same classifications with the addition of atmospheric air. The atmospheric air class not only took care of the sun glint, but also the shadows of buildings. In the before image, majority of the classes were correct. However, some of the roads in the image were classified as brown vegetation. In the after image, I had a problem trying to decide whether the vegetation was brown or green. I asked some peers for their opinion and concluded that the vegetation was brown. The biggest difference between the before and after images is the change in vegetation. Another change is the amount of sand. The hurricane pushed the sand further inland to cover roads and areas with destroyed buildings. In this map, the study area is St. Joseph Peninsula State Park, which is a few miles south of Mexico Beach. This study area has no development and is known for its giant sand dunes. The purpose of this map is to see if there is any elevation change caused by the hurricane. The before hurricane LIDAR data was collected in February of 2018, and the after hurricane LIDAR data was collected on November 8, 2018. The LIDAR data was collected by NOAA. Before creating these images, I hypothesized that there was going to be a drastic change with the sand dunes. However, there is no drastic change noticeable. I concluded that this was because the trees and other vegetation protected the dunes from altering. I ran the minus tool to note if there was any changes. The major change was along the coast and the sandbar. In conclusion, this project will help understand the impact of a Category 5 hurricane, not only in the community but also with the environment. This project only focuses on the immediate impacts. Further study will be needed to show the long-term impacts. It has been 1 year since the storm hit, and the community is still working on cleaning up and rebuilding. Hurricanes make such a huge impact on people's lives, and this will be the first step to showcase how.